Hey everyone, welcome to the AP Precalc 2.9 to 2.13 quiz review video. Let's get right into it. All right, so I'm just going to go through each one of these questions on the quiz review one by one and show you the worked out solutions. So for number one, the function h is given by log base 25 of x, which input value, what x value will yield an output value of -1/2. So what I'm going to do here is convert this from a logarithmic to exponential. So this in exponential form is 25 to the power of -1/2 is equal to x. And what is this? Well, the first thing I'm going to do is get rid of the negative exponent. So that is 1 over 25 to the 1/2. And then remember, the 1/2 is just the square root. So 1 over the square root of 25. This is 1 over 5, which should be equal to x. So that is going to be our answer for number one. For number two, we are expanding log base 5 and then 3y to the fourth over z squared. And so this, I'm going to split it up into log base 5, 3, plus this, and then minus this because z squared is in the denominator. So this is going to be log base 5, 3, plus log base 5 y to the fourth, minus log base 5 z squared, because that is in the denominator, so it's going to get a minus sign out in front. However, that doesn't match any of my answer choices. So the next thing that I'm going to have to do is move all the exponents out in front. So this should be log base 5, 3, plus 4 log base 5y, minus 2 log base 5z. And this matches answer choice C. So C should be my answer for number 2. All right, for question number 3, the exponential graph is shown in the exponential graph of f of x is shown above. Which of the following is the equation for the inverse of f of x? And so this is very key, right? We are not asking about the equation of the graph above, we're asking for the inverse of that equation. And so that's what you'll see a few times on your quiz is I'll ask you or give you information about the original function and then ask you a question about its inverse. So if we take a look here, we see the points 0, 1, we see 1, 4 there as our second point. And so if we take a look, just by knowing exponential functions, this should be 4 to the power of x. Very simple exponential function. However, then the inverse of this is going to be log with the same base 4 of x. So that means B should be our answer there for number 3. All right, for number 4, which of the following expressions is equivalent to log base 3, 7? So remember, this is going to be log base of any number, 7, over log base of any number 3, right, if we were to split it up. And it doesn't matter what that number is. It could be 5, it could be 10, it could be pi, as long as it's the same number. So let's take a look. A really doesn't match that, so we can eliminate A. B has 7 and 3 as the base, but not as the argument, so we can eliminate B. C has the same base, but unfortunately it's 3 over 7, not 7 over 3. And then D is ln, which remember, this is log base e of 7 over log base e of 3. So in this case, that number is just going to be e, which is okay. So D is the correct answer for number 4. Number 5, the function f is defined as log base 981 x squared. Which of the following is an equivalent representation? So here I'm going to split this multiplication up because this is 81 times x squared on the inside into the addition of two logarithms. So I'm going to write this as log base 981 plus log base 9 of x squared. Once we have this, that doesn't match any of our answer choices, but log base 9 of 81 I can rewrite as just 2 plus log base 9 x squared. Fortunately, it still doesn't match any answer choices, so I'm going to take this 2 and I'm going to move it out front. to get 2 plus 2 log base 9 of x, which should get D as the correct answer there. Right? Number 6, let g of x equals log base 7x plus 2, which of the following gives the domain of G? This is pretty easy. It should just be A. And the reason for that is because, sure, there's vertical translation, but that has no effect on the domain, right? The domain is going to be affected by horizontal translations that occur inside of there, and because there aren't any, A should be the correct answer for number 6. Number 7, the logarithmic function k is given by k of x is -3 log x. Write both limit statements. So we know this is a negative logarithm, so it's going to appear like this. And so both limit statements would be, the first one would be the limit as x, and then let's talk about as it goes to the left, right? It doesn't go to negative infinity because it's cut off by 0, that y-axis. So we're going to say as x approaches 0, the cutoff point from the right. So that's why we're going to put a plus there, k of x. And this, as we approach 0 from the right-hand side, right? So coming in from the right, this is going up to positive infinity. The next limit statement is going to be the limit as x approaches positive infinity. So as x goes to the right forever, this is going down. It's hard to see, but it will constantly decrease. So this should be negative infinity there. And that's our answer for number 7. For number 8, the graph of f is shown below. Which of the following could be the equation? This is pretty easy as well. We see it's cut off by the y-axis, right? So that means it has to be a log. Right? If it was not cut off by the y-axis, then it would span past it and it would be exponential. But in this case, it's logarithmic. And because it's constantly decreasing, or it's just shaped like that, that's going to be a negative a value, right? So you're going to see in the form of a log base bx, a should be negative in this case. So B is the only correct answer for that one. Number 9, the function g is given by g of x equals 5 to the power of x. Which of the following statements about the inverse is true? So the inverse is just going to be the logarithmic function with the same base, log base 5x. And then remember here, our domain and range for the exponential function. So our domain for the exponential function is all real numbers. That's fine. And then our range is going to be y is greater than 0. So then for this logarithmic function, our domain and range should be switched because they're inverses, right? So our our range is going to be all real numbers, and our domain, this should be D for domain, should be x is greater than 0. So our correct answer is B. The inverse of G is given by G inverse of x equals log base 5x, and is defined for only x is greater than 0. That is our answer for 9. Number 10, the table shows values of a function at selected values of x. Which of the following claim and explanation statements best fit this data? And so here we see that our inputs are equally spaced, right? +4, +4, +4, +4, and then our outputs change proportionately. So times 2, times 2, times 2, times 2. And so when you see an addition rule up top and a multiplication rule with your y values, this is going to be an exponential function, so you can eliminate C and D. And then because the inputs change proportionately, that's not right, so we can eliminate A. B is our correct answer. Because the outputs change proportionately, which means a multiplication rule, as the input values increase in equal length intervals. So that's perfect for B being the correct answer there. Right. A, the functions g, k, and h are given by this. We want to simplify all of these. So the first one, we're rewriting it into one expression. So simplifying this first, I'm going to take any coefficients out front, which it's just that 6, and move it to the exponent. So log base 10, x plus 2, minus log base 10, 4 minus x to the 6 plus log base 10, 7. Simplifying this, I'm going to then put one big log and then make a fraction. Anything with a plus sign is going to go in the numerator. So we have 7 times x plus 2. You can leave it like that or distribute if you want. But then 4 minus x to the 6 is going to go in the denominator. And this is going to be our answer, right? We're done here. No need to simplify anymore. For part 2, we're going to do the same thing. So let me move the 1/2 into the exponent here to get log base 4 2x minus log base 4 x plus 1 to the 1/2 minus log base 4 6. And so let's write one big log now. Log base 4, put a big fraction. 2x is going to go up top. 6 is going to go in the bottom. And so will the square root of x plus 1. Here, I would expect you to be able to make the simplification of canceling those out to get log base 4 x over 3 square root x plus 1, and that should be our answer there. So with anything multiplication based is typically simplifications you can make if possible. All right, number 3, rewrite this in the form with a base of 4. So let's rewrite that now. 16 is 4 squared, and this is to the power of 3x times 4 to the power of x, all over 2, which is the square root of 4. So 4 to the power of 1/2. This is then 4 to the power of 2 times 3x, which is 6x, times 4 to the power of x over 4 to the 1/2, which is 4 to the 7x, so adding them together, over 4 to the power of 1/2, which then should get us 4 to the power of 7x minus 1/2. So remember, we subtract the denominator exponent, and that's our answer for A3. 4 to the power of 7x minus 1/2, where in this case A is 7 and B is negative 1/2. You could leave your answer like this or like this. Either one is fine. For part B, here we're solving this log equation equal to 3. So let me set up the equation and then we can solve it. Log base 5, 4x minus 2 equals 3. Setting this up, 5 cubed equals 4x minus 2. 5 cubed is 125. And then solving this, adding 2 to both sides, 127 equals 4x. And then here, I'm just going to divide both sides by 4. I know 127 because it's odd isn't evenly divisible. So I'm just going to leave my answer as 127 over 4 equals x. And that should be the perfect answer there. Right, the next one, we are setting this equal to 3. So this is log base 3. And I'm going to combine these two, but when you're adding logs with the same base, you can multiply the insides together. So x minus 2 times x plus 4 equals 3. And now I'm going to convert this to exponential form. So this is going to be 3 to the power of 3 equals the insides of the logarithm, which is x minus 2 times x plus 4. Simplifying both of these, you get 27 equals, and then I'm going to FOIL this out as well. So this is a long one. X squared plus 4x minus 2x is just plus 2x minus 8. Continuing to solve that, subtracting 27 from both sides, you get x squared plus 2x, and then minus 8 minus 27 is minus 35. Factoring, you should get this to be x plus 7, x minus 5, to get x equals negative 7 and x equals positive 5 here. However, you plug in negative 7 into either one of those, you're taking the log of a negative number. So we're going to ditch that, and x equals 5 should be our only solution that does not provide any domain errors there. So our answer to part 2 is x equals 5. This is a long one, but be prepared for a question like that on your test as well. For part 3, solve the equation e to the power of x plus 5 equals 13. So I'm going to convert this from exponential to logarithmic. So this is going to be log base e of 13 equals x plus 5. I'm going to rewrite this as ln 13 equals x plus 5, and then subtract 5. So ln 13 minus 5 equals x, and that should be our answer. Make sure that you do not simplify ln. You don't write it like that because this is confusing to the reader or the grader, or don't try to simplify it to ln 8 equals x, because this is just all wrong. So don't do any of those steps there. The next one, here we are setting this equal to e to the power of 1/2. So this is e to the power of 5x, because we multiply it, minus 1/4, because it's in the denominator, equals e to the 1/2. And then we have 5x minus 1/4 equals 1/2, just setting the exponents equal. And then to solve this, I'm just going to multiply everything by 4 to get rid of the fractions. So 20x minus 1 equals 2. 20x equals 3. And then you should get x equals 3 over 20. No simplifications can be made there. So that should be our answer for x for part 4. Finally, part C. This is going to be an A method problem. The last one on your quiz as well and on your tests will always be an A method problem for now. So here, find all input values that yield an output value of 18. So I'm going to write this equation first. 2 to the power of x squared minus 3 times 2 to the power of x equals 18. I'm going to subtract 18 from both sides. The first thing I'm going to do actually is replace 2 to the power of x with the letter a. So a squared minus 3a equals 18. And now solve it like a quadratic. So a minus 6, a plus 3. Here you should then get a to be equal to 6 or negative 3. And then sub 2 to the power of x back in, tag it in. So 2 to the power of x equals 6, or 2 to the power of x equals negative 3. Then convert it to logarithmic form. So log base 2 of 6 equals x, or x equals log base 2 of negative 3. However, with a negative log, you can't do that, so you can't take the log of a negative number. So that would provide no solutions from that equation. But this, there's no simplifications we can really make, so that is just going to be our answer. X is equal to log base 2, 6. And if you have that, that should be good enough there. All right, if you have any questions on the quiz review, please come see me in office hours, and I will see you guys later. Thanks.